The crystals that we are all familiar with are solids that have repeating structures in space, like sugar or table salt. The same concept can be applied in time, too, as introduced by Frank Wilczek, a Nobel Prize laureate in 2012. According to Wilczek, time crystals are solids that have repeating structures in time, oscillating while in their ground state and breaking time translation symmetry while in equilibrium. But what's time translation symmetry? Well, it means that the laws of physics don't change over time. For instance, if I drop a ball now, then say an hour later, the results would be the same. In time crystals, however, their structures are changing, so they would look different in different points in time, breaking this symmetry. After Wilczek's publication, a team of Haruki Watanabe and Masaki Oshikawa refuted the possibility of time crystals, declaring that moving particles would have to expend energy, meaning that they would not be in equilibrium and would eventually stop moving. So, are time crystals still possible? Well, yes, if you look at it from a different perspective. A paper called Discrete Time Crystals, Rigidity, Criticality, and Realizations stated that making discrete time crystals was possible by totally scrapping this equilibrium thing. Instead, an external driving force makes atoms oscillate at a rate multiple to the force. After this publication, a team from the University of Maryland applied it with some ytterbium ions and a laser as the driving force. After shooting a laser through the ions, they began to oscillate at twice the rate of the laser's electromagnetic wavelength. What's more impressive is that when they stopped the laser, the ions continued to oscillate. At Harvard, a similar trend was noticed, where they used microwaves to force diamonds, to oscillate at 3 times the wavelength. This has serious implications in the scientific world by linking general relativity and quantum mechanics. In relativity, space and time are related, but in quantum mechanics they are regarded as very different. However, time crystals prove that patterns can form lattices in space and time, which could link the two fields. In addition, time crystals have the potential to help in quantum computing because they could be able to store information more securely and prevent hacking. More importantly, the creation of time crystals involved many teams of scientists working together and building off of existing research. These scientists contributed their own point of view and united together to solve a common problem. Therefore, time crystals perfectly display the power of thinking creatively and approaching problems from different viewpoints to find solutions that can benefit ourselves and the world.